Gentlemen, this is speed and velocity and correlates with chapter 9.2 in your textbook. Your key concepts for this video are: how do you calculate speed, how do you describe velocity, and how do you graph motion? So how do you calculate speed? Well, first off, you might have heard that speed is a rate. When we say something's a rate, we mean it's something divided by time. In this case, speed is distance divided by time. For example, if I ride my motorcycle 85 kilometers to DC, it takes me 1 hour and 15 minutes. What's my speed? Well, I take my speed equation and I plug in my distance of 85 kilometers. It's very important to include your units. And then I need to plug in my time, but I've got two different units here. So I'm going to have to convert my minutes into hours or my hours into minutes. I chose to convert my minutes into hours. 15 minutes is a quarter of an hour. So I have 1.25 hours. I just plug and chug the numbers and I end up with 68 kilometers per hour. You take the unit on the top and you have a little slash, meaning per, and the unit on the bottom gives you your unit for speed. It's sometimes helpful to be able to calculate how long it'll take you to get somewhere or how far you'll go given a certain speed. That's where this little triangle helps out. You set it up with distance on the top, speed on the bottom, and time also on the bottom. If I wanted to find out speed, I would put my finger over speed, and I would see that distance divided by time gives me speed. If I wanted to find out how long it's going to take me to get somewhere, and I know my distance and speed, I cover my time, and I do distance divided by speed, and that would tell me how long it takes to get somewhere. I can also find out how far I'm going to go, the distance I'll travel. In that case, I would take my speed and times it by my time. So this is a very handy tool as we explore our speed unit. Now there are two types of speed. We've got average speed and instantaneous speed. Average speed is the total distance divided by the total amount of time. So when you're in traffic, maybe you're moving quickly sometimes, maybe you're moving slower others, but overall the total distance you traveled divided by the total amount of time it took is your average speed. This is what we'll be using mostly in class. Now, instantaneous speed means instant, like right now. How fast are you going? And that's all instantaneous speed means. If you look on your odometer in a car, it will tell you your instantaneous speed. Now, we won't be calculating that in class because that requires calculus and finding derivatives, so that will be something you do in high school or college. So a quick example with average speed, we've got, I drive to DC, and for the first 20 minutes, I cover 35 kilometers, and then traffic gets bad for 10 minutes, and I only go 10 kilometers, and then it clears up, and I travel 40 kilometers in 30 minutes and make it to my destination. What is my average speed? Whenever I've got something like this, I like to underline the things that have the similar units in the same color. So I did all of my distance in red, and I'll do all of my times in blue. I'll check that my units for each thing is the same, and then I'll enter them into my equation. So for my total distance, I take my 35 plus my 10 plus my 40 kilometers, and I divide it by my 20 minutes plus my 10 minutes plus my 30 minutes, which gives me, 85 kilometers divided by 60 minutes, which gives me 1.4 kilometers per minute, or if I were to convert it, 85 kilometers an hour. So how do I describe velocity? Velocity is very similar to speed, but it includes one really important thing, the direction of travel. So velocity is the same thing as speed, but with a direction. So these Blue Angels, they are flying at a speed of some number per meters per second to the left. Or this cheetah here. Cheetahs can run up to 97 kilometers per hour. Really impressive, that's its speed. But if you were to say that it's running 97 kilometers per hour towards me, I'd be really, really worried. This is where velocity can be quite helpful. It has to include that direction. Lastly, we're going to talk about how you graph motion. So speed is graphed on a distance versus time graph. To find it, you would simply plot your points. So at 0 seconds, I've traveled 0 meters. At 4 seconds here, I traveled 10 meters. At 7 seconds, I was still at 10 meters. At 9 seconds, I'd gotten up to 20 meters, and so on. From there, what I want to do is I want to calculate my slope of a line, because the slope of the line will tell me what my speed is for that time period. So just like you've done in math class, you do rise over run, so 5 meters divided by 5 seconds. The speed of this section of time is 1 meter per second. So your slope of the line equals the speed. So when it's flat and there's no slope, it's a slope of 0, you're not moving. Really steep means that you're moving quickly. Very fast, a steady speed up. Very stationary, returning back home. And if it's a curved line, that means you're accelerating. We'll talk about that more later. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.